In longitudinal waves, the driving force is parallel to the propagation direction. So what that means is this person who's holding, like, let's imagine this is a spring or a slinky type thing. Their hand is here, and they are going to drive, the driving force is going to be back and forth like this. And the velocity of the wave is going to be in the same direction. Driving force back and forth, and the velocity is propagating in that direction. The driving force is parallel to the direction of propagation. Now, if we look at this over time, if we took this little green dot and we put a light on it, and a strobe light on it, and took a movie over time, what we would see is it vibrating back and forth over space. You would see it would vibrate around an equilibrium position, a 0 point, and it would reach an extreme point of x naught and another extreme point of negative x naught. And that, of course, it would be vibrating back and forth. And we said that it has a constant period. Well, a constant period, when the angular velocity is 2 pi over t, means that omega is constant. So a constant period means the frequency, the angular frequency, is constant. And that, if you recall, is the definition of simple harmonic motion. Constant period. In a separate video, I'm going to go over these are animations, 3 different types of waves. Longitudinal waves in motion, so you can see it actually happening. We're going to see a transverse wave in motion, and then 2 other kinds of waves. And the first of these is a water wave. And the thing to watch there is that there is a circle, and there's 1 dot, and that circle, when you trace out that particular particle, that red particle, as the wave passes by, the wave propagates in that direction, you see that that red dot will go in a clockwise circle. And the same thing down here, clockwise circle. And you can envision a series of other circles there like so. And this is what happens with every wave. There is a wave that's at a circle at the surface, but those circles are stacked on one another going down. And when you reach the bottom where the circles are no longer are extant, then you no longer there's no wave interference. And this is why waves break, because when this line comes into contact with the shore, those little circles that are trying to spin get hung up on the bottom. That's why it doesn't happen just at the edge, it happens at a distance out. Another kind of wave is a Rayleigh surface wave, and we would look there for a similar thing, except it's not circles, it's ellipse. And the direction is counterclockwise at the surface, and deep down it is clockwise. And so they're going in different directions. Counterclockwise, and then deep down clockwise. So again, you're going to get to see some animations and have those videos explained for you.